So for our last section of Module 7, we're going to talk about systems of inequalities instead of systems of equations. And I'm going to start off with a quick review on how to graph inequalities. We will go very quickly, I just want to remind you, but there is a whole video on it. If you need a more in-depth look at that, go back to our graphing inequalities video. But as a very quick review, graphing inequalities is just like graphing a line with 2 extra steps. Step number 1, you have to decide whether to use a solid line if you have the or equal to, or a dashed or hyphenated or dotted line if you don't. Then step 2 is you got to do the shading. And you do that by testing a point on one side of the line, deciding if those are the answers. If so, you shade that side, or if they're not the answers, and you shade the other side. So here's a couple looks at some things to notice here. See this first one, the inequality is greater than. It doesn't have the equal to, and that's why the graph has a dotted line on it. The second one does have the or equal to. That's a less than or equal to, and it has the solid line. From there, you would graph the line normally, like the first one, just the line is like y equals x minus 2. The y-intercept is -2, that's right here. The slope is 1, so it's up 1 over 1. And you would draw the line that way. Then you would test a point and shade. So like if I told you guys when we did this section earlier, I always like to test the point 0, 0. If I plug in 0 here and here, I get 0 is greater than -2, which is true, and that's why I shaded where the 0, 0 is. Same thing over here. If I test the point 0, 0, I put a 0 here, I put a 0 here, I get 0 is less than or equal to 2. That's also true, so I shaded the side where the 0, 0 is. And remember, you don't have to test the point 0, 0. I just like to because it's easiest for substitutions. But that was our very quick review on graphing inequalities. The reason I wanted to review that with you, when it comes to graphing a system of inequalities, or basically 2 inequalities together, what you do is you graph each of the 2 inequalities completely separately, like 2 separate problems, but you do them on the same coordinate plane, on the same xy axis. And the answer is the shaded region, it's the double shaded region, basically. You're going to have one inequality and you're going to shade part of it. You're going to have another inequality, you're going to shade part of that. The answer to the system is going to be the shape that is shaded by both graphs, the double shaded area. All right, so let's do this one right here. I'm going to take me out of here so I'm not in the way of the graph. And let's do each one. So the first equation, I'm going to graph it. Let me write it here so we can work on it. I'm going to graph it. First of all, just pretend like it's an equal sign. Y equals -2x plus 6. That's slope-intercept form. So this is the y-intercept, positive 6. 1, 2, 3, 4, 5, 6. Count up 6 and put a spot. This is the slope. The slope is -2. And remember, when the slope is a whole number, if you want to do rise over run, just put it over 1. So think of the slope as -2 over 1, which would be down 2 over 1. That would be right here. And, you know, that's enough. Maybe you want to do a couple more points, down 2 over 1, down 2 over 1, just to get the idea. But then you draw that line as best you can, like this. Okay. Actually, you know what? I got to go back a step because that was supposed to be a dotted line, not a solid line. So let's erase that. Let's redo that. The other thing before I draw the line is I look at the inequality and I say, you know what? That doesn't have an or equal to. So what I want to do is draw the dotted or dashed or hyphenated line going through those 2 points. That's better. And then I want to shade. Now remember, you can pick any point you want, but I always like to pick 0, 0, which would be right here. And I'm going to test 0, 0. I'm going to plug in a 0 for y, plug in a 0 for x, and what I get is 0 is less than, now see the negative 2x just disappears. It's like when we do the intercept trick, the cover-up trick. That just disappears. You get 0 is less than 6, which is true. 0 is less than 6. So I'm going to shade everything over here. This is my shaded area for the first line. Shade all that in red. And I'll do colors here so you can make it easy to see. Okay, now for my second equation, I had negative 2x plus 4y is greater than or equal to negative 12. Now see, we're just starting over here. You're doing two completely separate questions. I graphed an inequality just like we did last module, module 6. Now I'm going to do it again. Now for this one, I would probably do the cover-up trick, do the intercepts. Say I'm going to find the x-intercept by setting y equal to 0. And if y is 0, the 4y disappears. We get negative 2x. Remember, we're pretending it's an equal for this. Don't worry about the inequality yet. So negative 2x equals negative 12. Divide both sides by negative 2. And x ends up equaling, that would be positive 6. So my x-intercept, 1, 2, 3, 4, 5, 6 to the right would be right here. And then for my y-intercept, didn't work very well. Okay. For my y-intercept, we'll say x equals 0. And you get 4y equals 12. Divide both sides by 4. And y equals 3, positive 3. So my y-intercept is going to be up 1, 2, 3. It's going to be right here. And I'm going to draw, this time, a solid line, because this one does have the or equal to. Draw a solid line going through those 2 points. We'll test again. I'm going to test 0, 0 again, because I told you guys that's my favorite one to test. It's the easiest to plug in. I'm going to plug in a 0 here and a 0 here. And both of those turn into 0. So what I get is 0 is greater than or equal to negative 12. And yes, that is true. 0 is greater than negative 12. So forget, now this is where it can sometimes get a little confusing. Ignore the red, pretend like it's not even there. I'm looking at the light blue line, and I'm either going to shade that big area on the bottom or that triangle on the top right there. And this one is on the bottom. We're shading on the bottom here. We're shading where the 0, 0 is. So I'm going to shade everything kind of underneath that light blue line, all this area over here. Now the final answer to the question is the area that's double shaded, that's not light, or that is both light blue and red. So kind of think of it as your graph has been split up into 4 areas. Number 1, you have this triangle here that's red only. That's not the answer. Number 2, you have this area over here that's not shaded at all. That's definitely not the answer. Number 3, you have this area down here, which is blue only. That's not the answer. The answer is this area down here, and I'll kind of go over it in black again. This area down here that is both red and blue. All those points down here are our answer. The area that is double shaded, every point that is in the red and blue shaded area together is an answer to both equations. Anything that's not double shaded is not the answer. So that red triangle, not the answer. Blue triangle, not the answer. Empty area, definitely not the answer. The double shaded area, which I went over in black, is the answer to the question.